flip here. We're going to start right here. Okay. So it starts with complementary and supplementary angles. Raise your hand if you've heard of complementary, supplementary angles before. Not everybody, though. Interesting. So weird. Because I know at the very beginning of my teacher career, I taught it like elementary school, and even 4th grade, we were talking about complementary, supplementary angles. But it seems it has been left out for whatever reason. Okay, so complementary angles add to 90 degrees. So if you forgot that, that's what makes complementary angles. So in the example here, there are two angles. One is 27 degrees and the other is 63 degrees. And those add to 90 degrees, making complementary angles. Then supplementary angles add to 180 degrees. So when you add these two together, 60 degrees plus 120, you get 180. So therefore, these are supplementary. So here's a couple sample questions. It says, find the complement of 27 degrees. Well, the two angles would have to add to 90, so you can do 90 minus 27, and so the complement would be a 63-degree angle. And then for number 2, find the supplement of 115. Well, supplementary angles would add to 180, so you can do 180 minus 115, and it would be a 65-degree angle. Okay. Then the next two bring in algebra, so this would be like level 3. It says A and B are complementary, find the measure of each angle. We're going to just find x because there's not a lot of room here to solve everything, so for both of these, we're just going to find x. Okay, so these two angles are complementary, meaning they add to 90 degrees, so we're going to set it up like that. 5x plus 4 plus 7x minus 10 equals 90. And then we'll solve. So combine your like terms. Add 6 to both sides. Then x equals 8. Then, as you know, a lot of times they'll want you to actually find the each angle measure. You would just take the value of x and plug it in to find an angle measure if it asks. Then number 4 is similar, but now the angles are supplementary, so that means they add to 180. So this plus this will equal 180. And just solving here. And x equals 9. Pretty simple. Okay, so now we're going to go back into vocabulary. And it's going to talk about angle pairs. The first set of angle pairs we're going to talk about are adjacent angles. The word adjacent, does that word sound familiar to you? Adjacent means like right next to. So adjacent angles are just angles that are right next to each other. They have a common vertex and a common side, and they're adjacent. So like here, angle 1 and angle 2 are adjacent. What's the importance of that? Well, the importance is if you were told that this was like 46 degrees and this is maybe 50 degrees, with adjacent angles, you could find the measure of the whole thing by just adding those two numbers together to get, for example, 96 degrees. Good. Okay, so down here it asks if they are adjacent, so we just look at each example and decide whether it's adjacent. It would have to have a common vertex and a common side. Here, common vertex, common side. So yes, Those two angles are adjacent. This one, they kind of share a side, but they don't share a common vertex, and we couldn't like add those two numbers together, so no. This one, they don't have a common vertex, so nope, not adjacent. This one is adjacent, so these two angles share side, share vertex, so yes. This example's kind of weird. I think the angles are overlapping, but it's hard to see. I don't want to confuse anybody, so just cross that out. And then when you're ready, flip it over. Okay, next angle pair is a linear pair. Linear pair. Linear from algebra means a straight line. A linear pair of angles are adjacent angles that form a straight line. And the key here is with a linear pair, the two angles are going to add to 180 degrees. So a lot of times they'll leave that detail out of the problem because they expect you to know that a straight line makes a 180-degree angle. So here, they're adjacent. You have the two opposite rays right here. They're supplementary, meaning they add to 180 degrees. So like if this is 60 degrees, you could solve for this one to get 120 degrees. Okay, so examples of a linear pair are like what we just saw with a straight line. So like angle 1 and 2 here are a linear pair. Another way it shows up a lot is with intersecting lines. So if we have two intersecting lines, you have like a linear pair right here and here. So if you were to cover up this part, there's a linear pair right here. Or you could go all the way around, like these two are a linear pair, so are these, and so on. So there's a bunch of linear pairs here. Non-examples, I'm not going to confuse you, so just cross that out. Okay, then the next one, vertical angles. Vertical angles. If there was like a most popular award for angle pairs, it's this one. This one will show up on literally every test you have in geometry, vertical angles. Vertical angles are opposite each other and they're equal. So for example, angle A here and angle A are vertical angles and they're equal. So if we're told that this is like 60 degrees, then this would be 60 degrees. So examples, they are formed by intersecting lines. An example would be, okay, this angle is the same as this one. Those are vertical angles. Also, there's vertical angles here and here. And the same number of like arc marks means that those angles are equal. Non-examples, we're not going to confuse ourselves. Okay, then in this section right here, it's just some practice. We're going to cross out the first two. It says determine if the angles are vertical angles, linear pair, or neither. Okay, so the first one, angle 4 and 5. So here is 4 and here is 5. Those two angles are a linear pair. They come together to form a straight line right here. Does that make sense to you? Some people in my last class were looking at the line instead of the angle and they were getting confused. So if you have questions, let me know. 5 and 8. So here's 5 and here's 8. They're definitely opposite, so they are vertical angles. And then 4 and 9. Here's 4, here's 9. They're opposite, they're vertical angles. And then 5 and 6, neither. They're not like adjacent or anything, neither. And 1 and 4, those are neither as well. They have a relationship, but we haven't learned about it yet. It comes up in another chapter. Yeah, what's up?
How come 1 and 3 are?
1 and 3.
It's like number 8. Why?
Because it's not opposite. Like if this went 1 and this was like 5, 1 and 5 would be vertical. Yeah, we'll look at this whole situation more. It comes up in other chapters and there'll be more relationships. But okay, ready for the next page? Slide it over. Perpendicular lines. I hope you've heard of this before, especially in algebra. Perpendicular lines are two lines that intersect and form a 90-degree angle. You'll usually see a little square there. That means that this is 90 degrees. And with this being 90 degrees, everything else will be 90 degrees. So once you have one angle labeled here, all the others have to be 90 degrees. Because vertical angles are equal. Also, these would add to 180, so this would have to be 90. Vertical angles equal, so yeah. Once you have one labeled, they're all 90. The notation for perpendicular lines, so you can say that line AB is perpendicular to, and this is the symbol for perpendicular, line CD. And that means that it forms the 90-degree angles. Okay, and then this chart that I had you fill in, these are just like clues as to when things are equal, add to 90 or add to 180. So words that would mean equal would be congruent, a bisector that breaks things into equal parts, midpoint, where both sides would be equal, or vertical angles, which are going to be equal. Things that add to 90 degrees would be complementary angles, right angles, or perpendicular lines. And then 180, some keywords would be supplementary, a linear pair, which those angles would be supplementary, and opposite rays, which would form a straight line, which is again 180 degrees. And then the bottom chart right here, we're going to go through some examples with the algebra. Each setup here, we're going to look at what type of like relationship those angles have. So here it shows vertical. And so that means that those two are going to be equal when we solve it. For this one, we have vertical angles again. They're going to be equal. Then for number 3, those two angles are supplementary. They're a linear pair, I guess is what I'll write. They're a linear pair and they'll equal 180. And then these two form a right angle. They're going to be complementary. They will equal 90 degrees together. Okay, and then we'll solve each of these. So for vertical angles, we can just set those equal. Those are like the easiest ones to figure out how to set up. So I'm just setting them equal, solving for y. Okay, the next one, setting them equal, solving for x this time. I'm going to skip this one because I'm going to need a little bit more room for that. But the complementary angles, those two added up will equal 90. So I do x plus 30 equals 90. Okay, and then number 3, it'll be this plus this equals 180. So I'm going to just like draw an arrow and put it down here. 25x plus 8 plus 9x plus 2 equals 180. X equals 5. And that is all. Actually, there's one more that comes up on the homework that I want to go over. I just put it on the board too. I'll put it here. Oh, sorry, I don't want to. I'll zoom out. Okay, there's one on the homework that some people are getting stuck on, and I don't blame them. So I'm going to go over it right now. So here, let's say we have angle A, B, E. We'll call this C. And then the problem says that angle CBE is 3 times the measure of angle ABC. What is angle CBE? Okay, and then I also showed that that's 90 degrees. So for this one, I think the best way, there's different ways to do it. I'm sure some of you who are really like smart already figured it out. But one way to do it that's pretty easy is say, okay, if this is 3 times the size of this, just call this 3x and call this x. And then x plus 3x equals 90. And then you can solve it like that. What's 90 divided by 4? 90. 22.5. Oh, I didn't mean for it to be a decimal, but okay, so x equals 22.5, and then that would be the smaller angle, and then 3 times that would be the larger one, which is what it's asking for. So 3 times 22.5 equals 67.5 degrees. And that's how you could figure out that, just by kind of using algebra to figure it out. Okay, with the homework, if you have any trouble, let me know, even if you need help with just the setup. Once you're done with the homework,